Okay, now we're going to be talking about, and I don't even know that you can see this. Nope, you can't. So piecewise, these are called piecewise functions. It is one function. So right here, w of x is one function that's broken into two pieces. So one graph on this side might be doing one thing, but the graph on this side of this value might be doing something else. So let's see what we have here. Well, this first function says w of x is equal to x squared, but only for the x values that are less than 2. So we wouldn't even be able to see this over here. So let's look at that. So x squared, so that graph looks something like this. Well, 1 squared is 1, 2 squared is 4. Then we're going to come over here, do the same thing. And that graph is going to be doing this. That's x squared. But this says, but the only thing that we can look at is, whoops, dang it, I did not mean to do that. I'm going to make that eraser much smaller. So when x is 2, it's all the values less than. So in this case right here, since when you put a 2 in there, you get 4, there would be a hollow dot for this part of the graph. These are all the values that are, all of these values are smaller than 2. All right? I'm going to change my ink color now to red. Now we're going to look at this graph. Well, this graph is also an x squared, but we've been shifted over. The opposite of negative 2 is positive 2. So now we start this graph. So when we plug in 3, 3 subtract 1 is 1. 1 squared is 1. So it's going to go like this. So instead of, and that's a square bracket, so that's going to be a solid dot. So I'm going to make this really, really light. So instead of that quadratic doing this, that part we can't even look at. All we can look at now is this graph doing this and this graph doing that, and that is a piecewise. And so sometimes what you'll have to do is, okay, for this function up here, what is its domain? Well, it's all the values up, oops, I need to make that dark again. All the values up to 2, but not touching it. So for this function, its domain is from negative infinity up to 2. And then this function, it can touch right there when x is 2. So square bracket to positive infinity. And then the last thing that I want you to notice, here, let me choose it completely. I'll choose kind of a dark green. I don't know if that's dark enough, but I'll choose green and a little bit value. So then if we want to know about areas of increasing and decreasing, as we read left to right, all the way up to 0, that's decreasing. And then it increases there. And then there's this gap right here, and then it increases again. So when you're asked about functions that are increasing, decreasing, so for this one right here, you'd say from negative infinity up to 0, since it stops right there, that's a decreasing interval. And then from 0 to 2, this is actually a solid bracket. Could do this as solid bracket. But because of this hollow dot, that would get, that's increasing. And then solid dot at 2 to positive infinity, this one's also increasing, just like that. And there would be union symbols between each of those. All right, I'm going to go ahead and Let's see if there's another one. So let's look at this one right here. Well, when you have an f of x equal to a number, I might have messed this up, sorry. I'll pause. Okay, when you have f of x or y is equal to a number, this case 2, well, that's just a horizontal line at a height of 2. But this said the only ones that we can look at are the values that are greater than 2. And it's a solid line, so we can do this. And this function up here, put that one in blue, f of x or y is equal to negative 1x subtract 2. Well, that's a slope intercept. So at negative 2, we go down 1 over 1, down 1. But right there, when x is 2, that's a hollow dot. And then we can just keep going like this. So that's what those two graphs look like. And notice, if we were talking about increasing and decreasing, since that's constant, it's flat, this interval would not have an increasing or decreasing. This interval, all of these x's up until you get to 2, the graph, as you read left to right, so from negative infinity up to 2, that's a decreasing, and from 2, it's neither increasing or decreasing. Then when we talk about domain, so this entire graph, this is what's going to dictate the domain. So from negative infinity up to 2, and then we'll put the flat union, and that's a solid line, so square bracket. This one is from 2 to positive infinity, and those are the domain values. Then sometimes you're going to have 3 graphs, and so you have to look at each piece, but it's all part of one function. All right, that's it for Piecewise.